What happens if a skyscraper catches fire? Imagine you're on the 85th floor of a skyscraper. Suddenly, the fire alarm sounds. Smoke begins filling the hallway. The elevators stop working. Looking out the window isn't an option. So, what happens next? Most of us never think about this. We ride elevators every day without a second thought. We walk past stairwell doors we've never opened. But somewhere, deep in the architecture of every tall building, there's a hidden plan. A plan built for the one day nobody wants to see. And that plan started forming years before the building even had walls. Here's the strange part. A fire in a skyscraper is not just a bigger version of a house fire. It's a completely different problem. In a 2-story house, you can be outside in under a minute. In a super tall tower, the people on the top floors are farther from the ground than the length of 10 football fields. You can't just run outside. There is no outside close enough to matter. So the first question becomes obvious. If thousands of people can't get out through the front door in time, how does anyone survive at all? The answer isn't really about escape. It's about something engineers call defend in place. And to understand it, we need to start with the thing everyone assumes will save them, the elevator. Why the elevators shut down? Elevators feel like the obvious escape route. They're fast, they're right there, so why do they stop working the moment a fire starts? The reason is simple and a little unsettling. Elevator shafts act like giant vertical tunnels. Heat rises, and so does smoke. If elevator doors stay active during a fire, that shaft can pull smoke upward through the entire building, feeding it to floors that were never even near the fire. Elevators can also get called to the fire floor by heat sensors, opening their doors directly into flames. And if the power fails or cables are damaged, a car could stop between floors, trapping people inside a metal box with no easy way out. So building codes require passenger elevators to automatically return to the ground floor and shut down the moment a fire alarm triggers. It's not a malfunction, it's a decision made in advance to protect the very people who would want to use them. But that raises the next question. If the elevators can't be used, then how do thousands of people escape a building that tall? The stairwell that isn't just a stairwell. The answer is the stairwell, but not an ordinary one. In a skyscraper, stairwells are treated as one of the most protected spaces in the entire structure. They're enclosed by fire-rated walls designed to resist flames for 1, 2, sometimes 3 hours. The doors are fire-rated too, and they're built to close and latch automatically. So even if someone leaves one open in a panic, it seals itself again. But there's something even more clever happening inside those walls. Many stairwells are pressurized. Fans push clean outside air into the stairwell, creating air pressure that's slightly higher than the pressure in the hallways outside. That pressure difference means smoke physically cannot push its way in, even for a few seconds when a door opens. It's a wall made of air, invisible, holding back one of the most dangerous killers in any fire. Because here's a fact that surprises most people. Smoke, not flame, is the leading cause of death in building fires. Superheated smoke is toxic, disorienting, and it can fill a hallway with zero visibility in under a minute. So if smoke is the real danger, how do engineers stop something invisible and fast-moving from spreading through an entire tower? Compartments, sprinklers, and the fight to contain fire, the strategy is called compartmentation, and it's one of the oldest tricks in fire engineering. Instead of trying to stop a fire from starting, engineers accept that a fire will happen somewhere, someday, and design the building to contain it to one small area. Floors, walls, and structural columns are wrapped or coated in fire-resistant materials. Steel beams, despite being metal, actually weaken dramatically under intense heat, so they're sprayed with fireproofing material or encased in fire-rated drywall to buy time. Often 2 hours or more before that steel would lose its strength. Fire doors and fire-rated floor assemblies are designed to stop flames from punching through to the level above. In theory, and usually in practice, a fire that starts on floor 40 should struggle to reach floor 41. Then there are sprinklers, which are almost unreasonably effective. Studies from fire protection agencies consistently show that sprinklers control or extinguish the vast majority of fires before firefighters even arrive, using only the heads directly above the fire, not the dramatic everything drenched at once scene from movies. Only the sprinkler head that detects heat directly above the flame activates. And above all of this sits the building's nervous system, smoke detectors, heat sensors, centrifugamenti, and control systems tied into the fire alarm. These systems don't just make noise, they can automatically shut down air handling units so smoke doesn't travel through ventilation ducts, pressurize stairwells, and unlock certain doors for evacuation, all within seconds of detecting a problem. So if the fire is contained, the smoke is blocked, and the sprinklers are already working, does that mean the building is completely safe? Not quite, because there's still the matter of the people who simply can't walk down 80 flights of stairs. Refuge floors and the elevators firefighters trust. This is where super tall buildings, the true giants, hundreds of meters high, add another layer most people never notice. Refuge floors. A refuge floor is a designated level, sometimes every 20 or 30 floors, built with extra fire protection and direct connection to pressurized stairwells. It's a safe waiting zone for people who can't continue down the stairs immediately. Someone with a mobility impairment, someone injured, or simply a crowd that needs to pause and let the stairwell keep flowing safely. Buildings like Taipei 101 and the Petronas Towers use this design. It's not an escape route by itself. It's a pressure valve, a safe pause point in a very long journey down. But if the people can wait, someone still has to go up. So how do firefighters reach a fire that might be 600 meters above the ground? This is where firemen's elevators, also called firefighter service elevators, come in. These are separate from ordinary elevators. They have their own backup power supply, protected wiring, and controls that only emergency crews can operate once a fire alarm activates. They're built to keep functioning even when regular elevators shut down, giving firefighters a way to move heavy equipment upward without exhausting their air tanks by climbing 60 flights of stairs first. Once firefighters reach a floor near the fire, they don't simply run in with hoses blazing. They usually attack from below using a dedicated firefighting water system called a standpipe, essentially giant plumbing built into the building with valves on every floor so hoses can be connected without dragging water up from the street. It's slow, careful, methodical work, floor by floor, valve by valve. How September 11th changed everything. Now here's where the story gets heavier. Because for decades, these systems were considered more than enough. Then came September 11th, 2001. The collapse of the World Trade Center towers was studied for years afterward by engineers and investigators, most notably in a major investigation by the U.S. National Institute of Standards and Technology, known as NIST. Their findings reshaped skyscraper safety around the world. The investigation found that the impact of the aircraft knocked fireproofing material off structural steel across multiple floors, something building codes at the time hadn't fully accounted for. Without that fireproofing, steel beams and columns were exposed directly to jet fuel-fed fires, burning at extreme temperatures, weakening the structure faster than designers had ever expected. The investigation also highlighted that the building's single central stairwells, damaged by the impact, left many people on upper floors with no usable path down at all. The changes that followed were significant. Fireproofing requirements became stricter, requiring materials that adhere more strongly to steel, even under impact or vibration. Codes in many cities began requiring wider stairwells, additional stairwells, or extra pressurization redundancy in very tall buildings. Photoluminescent markings, glow-in-the-dark strips, were mandated along stairwell paths so people could find their way even if all power failed. And elevators designed for occupant evacuation, not just firefighter use, began appearing in newer super-tall towers, giving people on extremely high floors an additional option beyond an hours-long stair descent. So after all of this, the pressurized stairwells, the fireproofed steel, the sprinklers, the refuge floors, the firefighter elevators, is a skyscraper fire actually survivable? Mostly, yes. But here's the uncomfortable truth. No system is perfect. What still makes skyscraper fires dangerous, even with every safeguard in place? Real fires expose real limits. Fireproofing can be damaged by impact, age, or poor maintenance. Stairwell doors get propped open by careless habit, breaking the pressurization seal. Evacuation still takes time. For a fully occupied super-tall building, A complete stair evacuation can take well over an hour, even when everything goes right. Panic, crowding, and unfamiliarity with a building's layout can slow people down in ways no engineer can fully predict. And in developing fires, especially ones involving unusual fuel loads or unexpected structural damage, conditions can escalate faster than any drill ever simulates. This is why fire safety engineers don't talk about making skyscrapers fireproof. That word barely exists in serious fire engineering anymore. Instead, they talk about buying time. Time for people to walk down, time for firefighters to walk up, time for smoke to stay where it's supposed to stay. The quiet truth behind every tall building. So if you ever find yourself on the 85th floor when an alarm sounds, here's what's actually happening around you, even if you can't see it. Fans are pressurizing the stairwell you're about to enter. Sprinkler heads above the fire are already responding. Fire-rated doors are sealing themselves shut behind you. A separate elevator, one you've never used, is carrying firefighters upward on its own protected power line. And somewhere below, on floor after floor, refuge points wait quietly in case anyone needs to pause. None of this happened by accident. Every piece of it was designed years before the fire, argued over in code committees, tested in labs, and in some cases learned the hardest way possible through past disasters. And that's really the point of this entire story. The safest skyscrapers were never the ones built to assume a fire would never happen. They're the ones built by people who assumed from the very first drawing that one day somewhere it would.